So we're going to start working with exponential functions, growth and decay both. So just as a reminder, general form of an exponential, y equals ab to the x, and the a value here, and this is going to apply today, is going to be the initial amount that you start with. We're going to go through and I'm going to kind of explain that in each one of these examples. And then b is going to be your growth or decay factor, depends on how the question is worded. And x is going to represent time. And then y will change for each of these things depending on what the question is talking about. Now, there's two different ways you can find b, which is either the growth factor or the decay factor. So we'll have to use clues in the question to decide whether we're increasing or whether we're decreasing the amount that we're working with. And I will explain that, kind of what words to look through as we go through the questions. But there's two ways to determine. If you have growth factor, b is going to be 1 plus r here. R represents the rate, and that will be as a decimal. Most of the time these questions will give you the rate as a percentage, so we'll have to convert that to a decimal. And then the decay is going to be 1 minus the rate. So let's just jump right in. So the first example here says population of a city is 180,000 people and is decreasing. Okay, so decreasing is going to be a word that's going to indicate to you that we're going to have decay at a rate of 5% every year. Find the growth or decay factor and then write an exponential model for the population. And then we're going to use our model to determine the city's population after 6 years. Okay, so our initial amount is going to be the population of the city. So that's going to be the a value. And the decay, since we're decreasing at a rate of 5% every year, here's how we'll determine this. This is decay, so it's going to be 1 minus our rate. Okay, 5%, if you're not sure how to write that as a decimal, what you want to do is just take your percentage and divide that by 100, and that will give you the decimal for your rate. So here it's going to be 0.05. So what I want to plug in for b then is going to be 0.95. A way I like to think about this is the population is going to hold 95% of its people. If I'm decreasing at a rate of 5%, I'm still going to hold 95% of my population. So for my model here, here's my model. It's going to be y equals 180,000 times 0.95 to the x. And x is going to be time here. Y in this situation is going to represent what the population would be after we plug in a time for x, and x is going to be in years. So I just drew a little line here. So after 6 years is what the question then wants us to evaluate. You guys can see I pulled my calculator out here. What we would do is just go ahead and plug in 6 for x to evaluate this. Okay, now remember, don't multiply these numbers together. I would just type it into the calculator, 180,000, and then I'm going to do 0.95 to the 6th power here on my calculator. And let's see, I guess it doesn't say what we want to round to here. So I'm just going to go ahead and, oh, that's not showing up on the screen very well, guys, sorry. I still can't see it. Hang on. There we go. So I want to write down, forgive me, I don't know why this is not showing up right. Okay. I'm going to go ahead and round it to the nearest, since we're talking about a population, I'm going to round it to the nearest whole number. And so y is going to be here. 13231, let's say 7 there, round that up. So about 132,317 people after 6 years. Okay, now my second example, this says a house is purchased at $55,000. That's going to be your A. Appreciating. Appreciating means increasing in value, so this is going to be growth. And my rate here, this is going to be the 3.5%. So my value of my home is going up 3.5% every year. Find the growth or decay factor. Write an exponential equation. Growth or decay factor here, this is going to be growth. So we're going to do 1 plus our rate, and 0.35 is 0.035 as a decimal. Just take that percentage, divide it by 100. So when I plug this in, it's going to be 1.035 for our growth factor. Our model is going to be the A value, the initial amount you paid for the house, 1.035 to the X. The model should have an X in it. Because when we have the model, we can plug in any value for X and determine after any number of years. So when it asks you to write the model, make sure you have an X and a Y, and you're just replacing the A and B. Then when it asks you to answer the question, how much is the house worth after 10 years, that's when you're going to plug in a value for X. So after 10 years means we're just going to put in 10 for X. So to evaluate this, I'm just going to grab my calculator here real quick and type that in. And hopefully it shows up better here. We're going to do 155,000. Oh, I don't know why I can't see that very well, guys. Hang on a second. Okay, guys, I'm going to kind of tip the calculator here so it'll show up. So 155,000, that was what you paid for the house. 1.035, and after 10 years, we're just going to put that to the 10th power. Now, we're talking about the cost of the house, so I'm going to round this to 2 decimal places. And so 218,642, we're talking about money, and so that 0.807, I would round that to 0.81. So after 10 years, that house has increased in value to be $218,642.81. Okay, so we're keeping practicing here. A new truck sells for $29,000. That's going to be your A value, your initial amount. Now, depreciates is another word that's going to indicate decay to you. So that's going to be decay. So my B value is going to be 1 minus the rate here. 12% is the rate. And write a function that models the value of the truck. Okay, so we paid $29,000. My B value here is going to be 1 minus the rate. The rate is losing 12% of its value, so this would be 1 minus 0.12, which is going to be 0.88. Again, I like to think of that as like, what is the value that the truck holds? So it's going to hold 88% of its value there. And then to the X, this will be our model. And then if you continue to read the question, it says find the value of the truck after 7 years. So all I would do to determine that is go ahead and plug in 7 for X. And for this one, again, I'm going to round to the nearest hundredth because we're talking about money. So 29,000 times 0.88 to the 7th power. And so what's the truck still worth? $11,851, and I would 592, so I'm going to go 59, so 59 cents if we're talking about money. All right, and then I got one more here. An investment of $75,000, that's going to be your A. Increases is going to indicate growth to you at a rate of 12.5% per year. Find the investment's value after 30 years. So doesn't tell me I have to write out a model here. So my answer to the question just has to be what's the investment worth after 30 years. So B here is going to be 1 plus my rate. My rate is 12.5% as a decimal. That would be 0.125. So my B value for this question, we're increasing our value. The 1 holds for what you already have, and the 125 actually adds on to that to increase the amount. So our model would be 75,000 and then 1.125. Now, if I was doing the model, I would put to the X power. doesn't say here I have to find that. It just says we need to find what the account is worth after 30 years. So I'm going to go ahead and plug in 30 for X. And again, here we're talking about money. So when I get my answer, I'm going to round it to the nearest hundredth, which is going to be 2 decimal places. Oh, I'm sorry, guys. You can't see the... There. Sorry about that. I'm not sure why the lighting is doing that. So 256,000, or no, I did that wrong. 568,247.87. So after 30 years, this is actually at that percentage worth $2.5 million. And that's a good rate of investment there. All right. And then we're just going to do a little bit of algebra on the back that's not attached to a specific word problem, but still working with that formula. So it says, without graphing, determine whether the function is growth or decay, and then what the percentage of growth or decay. Now, on some of the previous stuff we've done, we've said neither. If it's neither, that means the A value is negative, and you'll see for none of these examples is that the case. So these are either going to be growth or decay. So just to remind you, growth is going to be a B value that's greater than 1, and decay is going to be a B value that is between 0 and 1. So we're just going to look at that B value. So right here, this is 0.12. And so to me, that's going to fall into the decay category, obviously, because 0.12 is between 0 and 1. And then we want to figure out the percentage of growth or decay. Okay, so remember, if you have decay, your B value is 1 minus the rate. So I can see the B value is that 0.12, and the rate can help us get to our percentage. Okay, so all I'm going to do real quick is I'm going to subtract 1. I'm going to do that 0.12 minus 1. And if I do that, this is negative 0.88 would be negative our rate. Those negatives cancel out. So 0.88 would be the rate. And if you want to tell it to me as a percentage, kind of like they were doing in the questions on the front, what you need to do is just take your rate and multiply that by 100. So this is going to be 88%. All right. Now, here, this guy also is going to be decay. 0.5 is between 0 and 1. There's different ways you can figure this out. Basically, what I just did here is a little bit more of an algebraic way. So again, this is decay, so 1 minus our rate here. I know this is 0.5. So if I subtract the 1, I'm going to get negative 0.5 is negative my rate, and then our negatives will cancel out there. So my rate is 0.5. Take and multiply that by 100 real quick. This is going to be 50% decay. All right, and then finally, this last one, that's bigger than 1, so that's growth. And kind of the same concept. The difference is, though, if you're working with growth, it's 1 plus the rate. So if this is 1.3, when I subtract the 1 here, I just get 0.3, and then that's actually equal to the rate. So I got to multiply it by 100 to get the percentage, and this will be 30%. Now, you don't have to go through and do this equation. You can kind of figure these out. Like if I see this 1.3, I automatically know whatever it is over 1, that's going to be my percentage. So 0.3, I know right away that's the rate. If it's between 0 and 1, what I kind of like to think about, if you don't want to do the process of kind of solving this little equation, you can just kind of think about, okay, what would I need to add that to get it to be 1? Because 1 would be 100%. So like here, if this is 0.12, I would need to add 0.88 to that to get that up to 100, and that can be another way that you can determine your growth or decay percentage. Okay, now, finally at the end, this is purely algebra, and we're going to use 2 points to write an exponential model in this y equals ab to the x format, and I'm going to work with you on how to do this. Okay, whenever you have points, those represent x and y coordinates on a graph. And I want an exponential model that goes through these 2 points. Okay, what I need you to do, you need to start and use the bigger x value. Whichever point has the bigger x value, that's the one I want you to start with. So the larger x value for this question would be the 2. Okay, so we're going to write 2 equations. They're going to be very similar, but we're going to plug in these points. So I'm going to use that y equals ab to the x. I'm going to write it over here. But what I'm going to do is I'm going to actually sub in those numbers for the x and the y. So for this point, start with the x value that's bigger first. So y is 5 when x is 2. The 2 variables we need to figure out here are a and b. And this is the fastest way you guys can do this. Okay, now this x value, smaller x value, do that second, but the same process. I'm going to write that ab to the x, but we're going to sub in 3 for y and 1 for b. So when y is 3, x is 1. Okay, now I probably haven't done this before, but this is like solving a system of equations. Like we would add the 2 lines together, subtract the 2 lines if we were working with lines. This is an exponential. So once I set this up, this is what I'm going to have you do. I am going to have you divide the top line by the bottom line. Okay, now the reason we do this, every time you set this up, you're subbing in values for x and y. So the b's will have exponents and there will be a number over here, but you will always just have this a over a. And the reason I'm doing this, if I divide the bottom line by the top line, a divided by a every single time is 1, and so it'll get canceled out. So when I divide this, now this doesn't actually divide nicely, it's just going to be 5 over 3. Okay, and then this is going to give you b squared over b to the first. If you want to skip this step that I'm doing right now, you totally can. But what's going to happen here, if I subtract my exponents, or if I say, where do I have more b's, the top or the bottom, this is going to end up just being 5 over 3 is equal to b. So let me explain that real quick. If I have b squared over b, those cancel right out. Or you could subtract the exponents. We could do b to the 2 minus 1. Or you can look at that and say, where do I have more b's, the top or the bottom? And then you're going to say the top, and you have one more. All of those methods work, but this is the b value. Then what we need to do is we need to find the a value. So I need to actually go ahead and substitute that back in, and you can pick either equation. I'm going to pick the one with the lower exponent. So I'm going to write 3 equals a. Now I know b is 5/3 to the first. So when I do this, I am using this equation right here. I'm just subbing in what we figured out that b was. Okay, now anything to the first power is going to stay that number. So 5/3 to the first is going to be 5/3. Okay, there's a couple ways you could do this. What I'm just going to do really quickly is I am going to get that 3 out of the denominator. You could multiply by the reciprocal. I'm just going to do this in 2 steps real quick. I'm going to multiply by 3. So this is going to become 9. Get that out of the denominator. And then this is a times 5. Divide by 5. And so that's going to give me then that 9/5 is equal to a. And those are the 2 things I need to write my equation. So then my equation, y equals ab to the x, would look like this. 9/5 times 5/3 to the x. You got to take that step to go back and write the actual model. So you're going to find a and b, and then you're going to actually put them together in an equation. All right, and I'm going to do one more, and then this guy is going to have some negative exponents. All right, now, a little tricky here. Like I told you, I would start with the bigger x value, and -2 is bigger in terms of its value than -4. -4 is smaller than -2, so I'm going to start with the -2 and 28. So y is 28 when x is -2. So if I plug that into ab to the x, I get 28 equals ab to the -2. Same thing, I'm going to do 112 equals AB to the negative 4. Okay, and then I'm going to do exactly the same thing we did before. Divide the top line by the bottom line. A divided by A is going to go here. All right, now I'm going to just grab my calculator real quick here. Hopefully I can get it to show up on the screen for you guys. Maybe not. So I'm going to do 28 divided by that 112. And that is, I don't know if you guys can see that. Sorry, there's kind of a light that's weird here. 0.25. And if I want to convert that to a fraction real quick, I'm just going to do second and then fraction to decimal here. And that's going to be 1/4. So right here we have 1/4. Okay, now let me do the exponents over here. So b to the negative 2 over b to the negative 4. If you want to go ahead and use exponent properties, these guys are just going to switch places and we move it and lose it. And so those exponents would look like that, and this would simplify to be b squared. Now you can also subtract the exponents if you want to do that property. This would be negative 2 minus a negative 4. Negative 2 minus a negative 4 is really negative 2 plus 4, so that's another way you could get the b squared. There's a couple ways to do this. But now I have an extra step that I didn't have in the previous question. So now to get b alone here, we have to take a square root. And when we're working with exponentials, the b value cannot be negative, so we do not want to put a plus and minus symbol here. All right, so no plus and minus because you cannot have a negative b value. All right, now here, the square root of 1 is just 1. The square root of 4 is 2. So that means our b value is 1/2. All right, now I need to find my a value. So pick either equation. I'm just going to go ahead and plug it into the very first one. I'm going to say 28 equals a. Now I know b is 1/2 to the negative 2. Let me just rewrite that real quick. 1/2 to the negative 2 power is going to be 1 to the negative 2 over 2 to the negative 2. These guys trade places. So I get 2 squared over 1 squared, which is really just 4 over 1. So that whole mess right there really means that 1/2 to the negative 2 power is 4. And then all I got to do to find my a is divide both sides by 4 there. And so a is going to be actually a nice number. It's going to be 7. So now I'm not quite done because I have to actually write the equation and plug those values back in. So y equals a b to the x. This would be my actual answer for the model of the exponential that goes through those 2 points.